Here we are adding or subtracting. And since it maintains the same units, we can just add them or subtract them as if they were just integers. So 5 plus 7 is 12. And then 12 minus 5 is 7. So this one is 7 kilometers. This is a digital lesson, so feel free to follow along on your computer or take notes in your workbook. We're going to move this point to split it into two small rectangle pieces. And then we're writing an expression for the total. So the total is a word that indicates addition here. We'll add the red rectangle and the blue rectangle together to get the total. This one asks us to split it into three small pieces. We're going to add these three chunks together. So the red plus the blue plus the green will give us the total. Move the points to divide it into smaller rectangles. So we have the red plus the blue plus the yellow plus the green. And then it says the expression that represents the total area of the given rectangle is 8x. You wrote 3.8x plus 4.2x for the first one, 2.8x plus 2.7x plus 2.5x for the second one, 2.25x plus 1.8x plus 1.7x plus 2.25x. What do you notice and what do you wonder about the expressions that represent the total area of the given rectangle and about the three expressions you wrote? If I were to combine 3.8 and 4.2, would that give me 8x? Write an expression that represents the total area of the given rectangle as a sum of the areas of the red and blue rectangle. Write an expression that represents the total area of the given rectangle as a product of x and the sum of the lengths of the red rectangle and blue rectangle. So this is using that distributive property like we saw in the last couple lessons. So with a width of x and a height of 3.4 plus 3.6. The product of those two would give us the area. I wrote these. Write another expression that represents the total area of the given rectangle. Well, if I add 3.4 and 3.6 together, 3 plus 3 is 6. 0.4 and 0.6 make another whole, so this is 7 times x. The height is 7 and the base is x, so 7 times x. I know this because 3.4 plus 3.6 equals 7. So x times 7 is the same as 7x. Write 3 expressions that each represent the total area of the given rectangle. Well, I have that the first rectangle would be x times 6, so it's 6x. And then this one would be 4 times x, so 4x. I could also think of it as the product of the base times the height, and the height of the whole thing is this 6 plus 4 piece. Or I could think of it as the total height. 4 plus 6 is 10, so this is x times 10. But we can rewrite that as 10x. Write 3 expressions that each represent the area of the blue rectangle. Well, the total height is 6 and the base is x, so the total would be 6x. And we don't want the red rectangle, so we can subtract the red rectangle's area. It has a height of 4 and a base of x, so it's 4x. We could think of it as the base times the height. Well, if the whole height is 6 and the height of the red is 4, then the height of the blue must be the difference between 6 and 4, which is a height of 2, so 2 times x. Here it wants us to write the expression as a product, so we're going to put the 5 and the 8 together, and those are multiplied by x. 5 plus 8 is 13, so this is 13x. If we had it written as a sum or difference, this would be 7x plus 9x. 7 plus 9 is 16, so this should say 16x. Here we'll have 10 minus 4 in the parentheses and the x outside. 10 minus 4 is 6, so this can be rewritten as 6x. This would be 7x minus 2x, because the x can be distributed. 7 minus 2 is 5, so this is 5x. Here's a diagram that represents 5x plus 6 plus 2x plus 4y plus 3 plus y. Make like terms the same pattern by clicking on the rectangles. Then combine rectangles of the same pattern into one large rectangle if possible. What do you notice about the rectangles that fit together to make one large rectangle? Well, the x pieces have the same width. The number pieces have the same width. And the y pieces have the same width. But I can't combine this up here because it's not the same width or the same base. So the rectangles that fit together all have the same width. The x pieces go together. Y pieces go together. And then the regular number pieces go together. If you click on them, you can change the pattern so that they match. And it says, can you combine the rectangle that has 4 y units with the rectangle that has 3 x units to make one large rectangle? Y. No. The y and x pieces are not like terms. They do not have the same width or pattern to them. Just like we tried to combine the y with the x here, you can see they're not the same type. Here's a diagram that represents this expression. Make like terms the same pattern by clicking on the rectangles, then combine rectangles of the same pattern into one large rectangle if possible. So here the x pieces, will make those all orange. And we can combine those. The number pieces we can make red. Oops. And combine those. And the y pieces will make green. Write 3 more expressions that each represent the total area of all the large rectangles in the diagram. Well, we can start with the x pieces, and those have a height of 7 plus 3. And then we'll add that to the number pieces. Those have a width of 1 and a height of 6 plus 5. And then we can add that to the pieces with the width of y. And that one has a height of 4 plus 1 plus 2. Then if we look at the total height of the orange, that would be x times 10. The total height of the red is 11. 6 plus 5 is 11. And the height of the y terms, or the y rectangles, 4 plus 1 plus 2 makes 7. So this can be rewritten as 10x plus 11, because 1 times 11 is 11, plus 7y, because y times 7 is just 7y. Then it says evaluate the expression you wrote when x equals 2 and y equals 3. So using this expression, we're going to evaluate it when x equals 2 and y equals 3. So we'll replace the x value with 2, and we'll replace the y value with 3. Well, 10 times 2 is 20. and 7 times 3 is 21. Then we will add 20 plus 11 is 31, plus 21 is 52. Here's a diagram that represents this expression. Make like terms the same pattern by clicking the rectangles, then combine the rectangles of the same pattern into one large rectangle if possible. Write 3 expressions that each represent the total area of all the large rectangles in the diagram. So make all the x pieces match. Oops. Make the ones with the y's match. This one has an xy, so we can make those match. And then this one's just a number. So our first expression could look something like this. 3x plus 5x plus 4 plus 2xy plus xy plus 6y plus 2.5y. Or we could just talk about the greens. It has a width of x and a height of 3 plus 5. Then the purple has a height or width of 1 and a height of 4. The red has a width of xy, and this one has a height of 1 and a height of 2. And then this one has a width of y and a height of 2.5 plus 6. If we find the total area of the green, 3x plus 5x is 8x plus the 4. A 2xy plus 1xy makes 3xy. And then a 6 plus 2.5 would make 8.5y. Here they've used the commutative property of addition to rewrite it so the like terms are next to each other. This one I have 2 c values, so I'm going to rewrite it so that the c pieces are next to each other. And then I have a 9 and a 1.9b. In this one, I'm going to put the t pieces next to each other. And then I also have s pieces, so I'm going to put those next to each other. And then I also have a number piece. In this one, I'm going to put the y pieces together. I have 2 number pieces that can be put together. And then I also have an xy piece. For the terms that have the same variable, I can put those pieces in parentheses. Here I have 4.5 and 3 t, and I have 1 and 5 s and a 2. In this one I have 5 and 3 over 2 for the y's. I have 6 and 2 for the numbers multiplied by 1. And then I have a 3xy. So I can combine the pieces inside those terms. 5 plus 5 is 10, so this is 10c plus 9 plus 1.9b. Here, if I add 4.5 and 3, that is 7.5t. 1 plus 5 is 6, so that is 6s. And then there's a 2. 5 plus 3 over 2, you can really think of that as 1.5. So that makes 6.5 y's. 6 plus 2 is 8 ones. And 3 xy pieces. Name 3 angles that you see in the diagram. Well, there's one here. There's one here. And then there's also one on the back side. Angles are labeled with 3 letters. So this blue one, we start at B or D, go to B, and then to C. You can pull up the little angle symbol. I'm not seeing it in the thing here, so we can just hit this, the slash, the / angle, and it'll pop up with that symbol. And we want to call it DBC. We also have this red angle, which starts at D, goes to B, and then to A. And then we have a third angle, which starts at C, goes to B, and then to A. It says, we can write the notation M with that angle symbol, which means the measure of angle XYZ to describe the measure of angle XYZ. Use the protractor to measure each angle, then complete the statements. So the measure of angle ABC goes from A to B to C. So this whole angle here. So if we count, that would be 10, 20, 30, 40, all the way up to, there's 170, 180. Then it says, what angle is 127? Well, you can see here, 10, 20, all the way up to 120, and then a little bit past it, so that's this angle here, which is the one that starts at D, goes to B, and then to A. What's the measure of angle DBC? So DBC. There's also numbers here on the inside. So we're going to start at C, and we're going to count 10, 20, 30, 40, 50, and a little bit. If we use these marks here, you can see it's 1, 2, 3 extra marks. So this should be 53 degrees. The ratio of angle COF to the measure of angle AOF is 8:3. Write two expressions that represent the measure of angle AOC. Well, that combines both 3x with the 8x. Well, 3x plus 8 more x is 11 x's. And then it says, well, what is AOC when x is 12? Well, we had 11 times x, and if x is 12, we need 11 times 12. Two times 1 is 2, 2 times 1 is 2, 1 times 1 is 1, 1 times 1 is 1, 2 plus 0, 2 plus 1, and then a 1. So this should say 132. And then it says use a protractor to check your answer. Well, we have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, and then two little marks past 130. So it is 132 degrees. The ratio of BOA to COA is 6:4. Write two expressions that each represent the measure of angle BOC. So we're combining the 6x with the 4x. 6 plus 4 is 10, so this is 10x. Well, what is the measure if x is 10? 10 times 10 is just 100. And then check. We had 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Make sure you have completed this lesson either digitally or in your workbook, and then check back for later lessons.